Hello, my amazing math students. This is Mrs. A, and I love math. And tonight we're on lesson 85, which means that we have about 35 lessons left in this book. So we're getting closer. And tonight we're talking about stem and leaf plots and histograms. Now, in this lesson, there are a lot of data points. So I'm going to be showing you in the book instead of trying to write all of these data points with my messy little hand on a board. So we're going to be showing you in the book, and then we'll do a couple on the board. Okay, so the very first thing we're going to do is analyze this set of 30 pieces of data, and these are the test scores that are made by a class of 30 students. So when we're analyzing the class's scores, we want to find mean, median, mode, and range so that we can understand where the center of our scores are. Now, when you're looking at a set of data like this, it's not very easy to tell much about the data. So we're going to put the data into a form where it's more easily visible. In other words, we'll be able to tell a lot more about the data if we put it in a stem and leaf plot, which is what we're going to do now. The first thing that they're going to do is find the mean of all the scores. Now, to find the mean, which is the same as the average, all we do is add up all the 30 scores and divide by 30. And there were 2,444 total when we added all 30 scores together and divided by 30. And that is 81.47. But in order to find the range, mode, and median is the middle score of the whole set of data. We have to arrange the data in a stem and leaf plot. Now, in order to do this, we're going to take all of the stems, which will be the first digit, the tens place of each number, and then we're going to represent each piece. Now, I'm going to show you on a piece of paper me doing this with all of those pieces of data here. Okay, I decided what I would do is I'm going to show you the first 6 pieces of data in that string of 30. Now, remember that when we looked at the data, the lowest tens place was 5, and the highest tens place was 9. Okay, so we're assuming that the top score of the test was 100, and nobody made 100 in that list. So the top in the list was appearing to be a 96 from first glance. So I haven't examined the scores, but I was just looking at them. So 5, 6, 7, 8, 9. So these would be our stems. And then we have our leaves. So basically, to put 92 in a stem and leaf plot, I'll come down here to the stem of 9 and I'll put a 2. 75 would be the stem of 7 and then the 5. And the 69 would be the stem of 6 and then 9. And 56 would be the stem of 5 and then 6. 88 would be the stem of 8 and then 8. 62 would be the stem of 6 and then 2. And we keep on doing this until we have every piece of data represented. So since I have 30 pieces of data, I should have 30 pieces of data as leaves to come off of the stems. So this helps us to organize our data and see the trends in our data. Okay, so here they're talking about the range and the mode and the median and how we have to have everything in order to be able to find the range. The range is the lowest point to the highest point, or the difference between the highest point and the lowest point. And if we don't know which one is the lowest and which one is the highest, that's hard to do. The mode tells us which point has been used the most, and then the median is the middle score of all the data. So we see as we move down that this is the finished product of all of our data. So we started it on the whiteboard, but they have finished it in your book. So there are 2 grades that are in the 50s. There are 3 grades that are in the 60s. There are 5 grades that are in the 70s, a whole bunch of them that are in the 80s, and there are 8 grades in the 90s. So you can see that the test is definitely top-heavy, and this method of displaying data is called a stem and leaf plot. The first part is called the stem, and then these are coming off the stems and tell you how many pieces of data you have in each one of these 10 space categories here. So now this is nice, this is nicer. And the reason this is nicer is because they have reorganized the leaves from lowest to highest, lowest to highest, lowest to highest. So now we have a much better picture of our data. So now we can go straight to our lowest score, 56, and straight to our highest score, 96. So our range would be 40 because 96 minus 56 is 40, okay? So here it says this stem and leaf plot has the same shape as the one above. So here we have this one. It looks exactly the same in shape as that one, but it's more useful because we're going from low to high in each one of the leaf sets here, okay? So it says we can use this one to arrange our data straight from here. So let's go from lowest, 56, 58, 62, 65, 69. And there they're coming up with the list all in order. So now they can take 96 minus 56 and come up with the range right away. They did up here, okay, the range. The median is the middle point of the data. Okay, so basically when we're looking for the median, we're going to count in from each of the ends of the data. Another way to do it is to know exactly how many data points you have. And we're going to always go to the center of our data. Since we have 30 pieces in this data set, we're going to say our median is halfway in between the 15th and 16th score on the chart. So we go to find the 15th score and the 16th score, and then we average those together. We can also do that from the stem and leaf plot. We could say, okay, I'm just going to count in. If I didn't know exactly how many pieces of data I had, suppose I had a really large set, and I said 1, 2, 3, 4, 5. Okay, so I end there, 1, 2, 3, 4, 5. So I go, okay, I'm going to count in a certain number amount until I finally get to the middle piece of data. Since we do know already that we have 30 pieces of data, we can count in 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But there are also 15 on the other side of the data. So we're going to have to take this one and average them together. And since that's in the 80s, that's 83 and 85. We're going to average those together so that we find 84 is the median or the middle of our data. This is exactly what they're saying right here. Okay, so now talking about the mode of our data in this paragraph. The mode of the data is also easy to find from our stem and leaf plot. I'm looking for repeated points. So here I have a repeated 4. So 74 is in there twice. Here 75 is also in there twice. 81 is in there twice. 87 is in there twice. 88 is in there twice. Okay, and so then I have 95 in there twice and 96 in there twice. So that is 7 numbers that were in there twice, but no number was in there more than twice. So this paragraph is telling you that because there were 7 numbers that were in there twice, we had 7 modes. None of them were in there more than any of the others. They were all in there just twice. Not a single number was in there 3 times. So we have 7 modes. And very often we'll have multimodal data. Modes don't mean a lot when there are 7 of them, but we still are sometimes asked to find them. So now let's look at this first example. Mark went to a driving range to test out the new golf club his brother Frank bought him for Christmas. He hit 20 balls in a row, and the distances the balls traveled were measured in yards as followed. Okay, so create a stem and leaf plot of the distances listed by using the first 2 digits of each number. Since they're 3-digit numbers, we're going to say that 15 is the stem and 0 is the leaf. So we're going to use the first 2 digits of each number as the stem and the last digit is the leaf. Find in which 10-yard stem the most golf balls landed. So here we go. So they're using as the stems 14, 15, 16, 17, 18. And they are carefully taking all of this data. So 150 would be on the 15 stem with a 0 at the end. 165 would be on the 16 stem with a 5 at the end. And so forth and so on. Okay, so here we come up with our stem and leaf plot. And now the only thing that they could do to improve upon that stem and leaf plot would be to put them lowest to highest. See, this is a stem and leaf plot that is not in the order. So it says, note that the digits forming the leaves do not have to be in any particular order. So here it says they chose to do it in the order that they appeared, but we could easily have gone from lowest to highest too, and that would have been giving us a little bit more information. Okay, so now we're going down here to example 2. It says find the range, median, mode, and mean of the data shown in this stem and leaf plot. So I'm going to show you the stem and leaf plot very carefully, and then we're going to show you that's the stem and leaf. And then if we took those stem and leaf, then we could find all the data pieces from it. 848, 849, 846, 848, 854, 852. Now, to find the mean, we would add them all up together and divide by the number of data plot points that we have. So we have 4. Okay, so we have, looks like 17 pieces of data, and that looks like it's right, 17 pieces of data. So we would add up all of these digits, 848, 849, and we would end up dividing by 17 pieces. So then they're showing us here that we can write all of the pieces of the data from the stem and leaf plot. And then once we have written them, now they are in order. So because we started with order here, 846 goes first. Okay, so 846, 848 is in there twice. 848, 848, 849 is next. 849. Now we move to 852. So a lot of times, people won't want to reorder it here if they're just going to write it in the right order here, because unless it's just a whole bunch of data points, you can pretty much eyeball it and say, okay, I'm going to pick 2 first because it's the lowest one. 852, 853, 853, 854. So this is really pretty easy stuff, okay? So now look, the scores range from 846 to 876. So what do we do for range? Lowest piece of data, 846 is the lowest one in the 84 range. And then 870, now we're picking the largest one, 6. 876. So from lowest to highest is 876 minus 846, and that is 30 points. Okay, we just subtract them to get the range. This set of numbers has an odd number of members, 17. So it does have a middle number. Odd numbers have a middle number. Even numbers, we have to take an average between the two middle numbers. So the median is going to be the number that is exactly in the middle of the data. Well, since we have 17, halfway between 17 is going to be the 9th point, because 8 doubled is 16 and 9 doubled is 18. So we have 17 pieces of data. So we're going to go to the 9th point. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 862 is the middle point of the data. It's a little tedious because it takes a while to get it done, but it's certainly not difficult. It's a pretty easy concept, isn't it? Okay, so here it says that there are 5 modes and that the mean is 860. Now the mean is just adding them all up and dividing by 17, the total number of points. But let's go look at those 5 modes again. Remember that modes look like repeated points on our stem and leaf plot. So we have an 8 and an 8. So that's 848. We have a 3 and a 3. So that's 853. We have a 2 and a 2. So that's 862. And we have 873 and 876 are both repeated points. And those are the 5 modes that they're talking about. Points that occur more often than the other points do. Now we're going to talk just a little bit about histograms. And histograms are the same thing as bar graphs. And a histogram, basically, if you took this stem and leaf plot, which was the data on the previous page, and then you rearranged it to, instead of going sideways, it's going straight up like this one is, and then you encase it with bars, you come up with a histogram. Now, a histogram does not have all of the data values in it like that. A histogram would just be bars. But notice that a histogram has the same shape as a stem and leaf plot that has been turned sideways. So it says on the right above, we show the same data displayed in a figure called a histogram, which is a bar graph of a frequency distribution. This graph shows us that there were 2 scores in the 50s, 3 scores in the 60s, which is the same information we had from our stem and leaf plot. Now, when you see a histogram without all of these pieces of data in them, you don't have the precise information like you do on a stem and leaf plot, but you do see how the data is distributed. Okay, so now here it says the speeds of 40 cars as they passed a checkpoint are shown in the frequency distribution table below. How many cars had a speed greater than or equal to 25 miles per hour and less than 30 miles an hour? Okay, so let's look at that information first. Here is number of cars. Okay, and here, down here is the speed that the cars are going. So it says that we're looking for how many cars had a speed greater than or equal to 25, but less than 30. Okay, so here we have 25 and less than 30. So this is the speed of the cars down here. And so if we're looking here, we would say 4 cars had a speed that was between 25 and 30. Okay, and then it says what was the mode interval. So the mode interval is going to be this one right here. That's the tallest. It had the most cars in that interval, and that would be from 35 to 40. Okay, and then what percent of the cars drove at a speed less than 40 miles per hour? So remember, percent is parts out of the total. So when we're looking at less than 40 miles per hour, so here is 40 miles per hour right here, and this is going up from there. So we're going to take off those, and we're going to go with these on the left. So we had 4, and then we add 10, and then we add 11. So 4 plus 10 is 14, plus 11 is 25. So we have 25 cars out of the 40 cars. So now we're going to turn that into a percent, which we're going to see on the next page. Okay, so here they have the solution, which we've already talked through most of this. Okay, so we have histograms and our frequency distributions that give you a good idea about how the data is laid out, but it is difficult to get exact information from them. Okay, so here we have the answers to the previous problem. Okay, it says between 25 and 30, there were 4 cars, so we already talked about that. The mode was this high one over here, which was between 35 and 40. And we talked about the 25 out of 40, and when we turn that into a percent, it is 0.625, or 62.5% of the cars drove at a speed less than 40 miles an hour. So now we're going to do our practice set here. And I'm going to work these on the board, but I wanted to show you the layout of these so that I didn't have to draw on the board all night long. But I am going to show you these on the board. So here, our practice problem is all like one big practice problem to cover all the different parts. So we have all of these data points from 20 slides with protozoa on them. Okay, so we're talking about this. We're going to make a stem and leaf plot first. So when I'm looking at my data, all of my data is 3-digit data. So I'm going to look and say, okay, what appears to be the lowest number that I'm going to start with? So I have here 111 and 118. I don't see a 10 anything. So I think I'm going to start with 11. So I'm going to start with 11. And if I find out that I missed a point, I'll go back and fix it. So we're going to make our stem. And then it goes all the way up to 145, 45, 150, 151. So we're going to say 11, 12, 13, 14. Okay, so I'm going to make my stems 11, 12, 13, 14. So now I'm just going to go to each one of these points and represent them. 132 would be on the stem 13 with a 2. 128 would be on the stem 12 with an 8. 136 will be on the stem 13 with a 6. 130 will be on the stem 13 with a 0. 142 will be on the stem 14 with a 2. 151 will be on the stem 15. Okay, I don't think I put 15 down here, so we need one more stem, and then we're going to put a 1. And then 111 would be a 1 on that stem. 123, 135, 145. Notice how I'm trying to keep them lined up so that I get a good visual of how many points I have in there. So that was 145, 127, 129, 148, 149, 150, 118, 139, 142, 150, 149. Okay, so now it's obvious that 1, 2, 3, 4, 5 points in the 13s, 1, 2, 3, 4, 5, 6 points in the 14s. Okay, so now let's answer our questions. The first question they said is find the range of the numbers counted. Well, I do not have them in order from lowest to highest within here, but it's pretty easy to see. So my lowest point is 111. My highest point is 151. So to 151. So my range is 151 minus 111, which is 40. So I have a range of 40. Okay, so then the next question is find the median of the data. Now, I already know that I have 20 pieces of data, and they are pretty much in order. Not quite, but we're going to count 10 in and draw a line because there's 10 coming from the other side. Since I have an even number of pieces of data, I'm going to have to average the two middle ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now remember this set of data is not in order. I'm going to have to put this set of data in order because this is the only one that's going to matter. But let's just count, make sure I have what I need. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it was 10 this way and 10 that way. So right in between those two pieces of data. But I have a problem. I have not put these in order yet. So the 0 goes there, and then the 2, and then the 5, and then the 6. The 9 is there, isn't it? So 0, 2, 5, 6. So let's erase these and put them in order. 0, 2, 5, 6. The rest being in order is just really not that important because these are the ones that are going to make a difference. Because this, now, I'm going to take an average between 6 and 9, and that's really 136 and 139. But if I just take the average between 6 and 9, won't it give me the same thing when I tack on the 13 in the front? It just makes the math a lot easier. Okay, so I'm going to take 6 plus 9 divided by 2, and that's 15 divided by 2, which is going to be 7.5. Okay, so 7.5. Added to, and then this is 1, 3 in front of that. So 137.5 would be the median. Now, to find the mean, I really do have to add up all of these things and divide by the number 20. Okay, so in order to do that, I will get my calculator and do it in a long line. Another way that you can do it is probably just easier to do it that way. Let's just do it that way. Add them all up and then divide by 20, and that gives you the mean. I will give you that in just a moment. I'm not going to take this off my board right now, though, but I will come back and do the mean for you and give you a calculated answer so that you can check yours and make sure you got the mean correct. Okay, so we did the range, we did the median, the mode. Okay, which piece of data happens the most? Well, we don't have any repeats here. We don't have any repeats here. We don't have any repeats there. 2, 5, 8, 9, 2. Okay, so we have a 2 there and a 2 there. We have a 9 there and a 9 there. Okay, and then we have a 0 there and a 0 there. So we actually have 3 modes. So let's figure out what those are. It's 142 is a mode. Okay, 149 is a mode. 150 is a mode. Now, if any one of those had been in there 3 times, then we would have listed that one point as the mode. Okay, but since we have 3 points that are in there twice, we have to list it all 3 and say, okay, we have 3 modes. The data is trimodal. Okay, so then the last thing that they ask us to do with this data is create a histogram of this same data. So that means that we're going to turn it sideways and do the data. I'm going to grab another board to do this. Okay, so now I was supposed to take our data and turn it into a histogram. So all I did was make a scale this way, number of slides, and this is how many protozoa were found on each one. So what I did was I took our previous data here and I said, okay, between 110 and 120 in that range, there were only 2 points, 2 slides that had that number of protozoa on it. So I reflected 2 on my chart over here. There were 1, 2, 3, 4 slides that had 120 something on it. There were 5 slides that had 130 something, and then there were 6 slides that had 140 something, and then there were only 3 slides that were 150 or more. So I took that and I actually put the number of slides that were found in each category. You don't usually do that on a histogram, but because I didn't have graph paper and my little scale is not the best over here, I went ahead and said, okay, there were 2 protozoa, 2 slides here, there were 4 slides, 5 slides, 6 slides, 3 slides. So that makes it easier for me to answer my questions. Since I didn't have graph paper, I don't have to keep on looking over here and trying to guess which one I had. Okay, so one of my questions in my practice set is, how many slides were between 120 and 149 inclusive? Now remember, we are starting each new set of protozoa at the 10 mark because that's how we set up our stem and leaf plot. So 120 would start here, and then 149 would be right before 150 started here. So we're talking about between 120 and 149 would include all of these. Okay, so I can tell you how many slides. That's 15 slides right there. So 15 slides were in between 120 and 149. And how many slides had fewer than 130 protozoa? So fewer than 130, since 130 is starting here, 6 slides had fewer than 130. So 6 slides. Now, if I wanted to turn that 6 slides into a percentage of slides, which they did ask us to do, we would say 6 out of 20 slides, because there's 20 total, which would be 3/10, which is 30%. Okay, so I've done everything from the lesson except give you the average that I told you I would give you on that practice set of data. So I'm going to go do that right now, and then I'll give you that answer. Okay, so the last thing, I added all of our 20 pieces of data from our protozoa slides, and I got 2,734, and I did it twice, so I'm pretty sure about that. So now we have 20 slides, so we're going to divide by 20. 20 goes into 27 one time with the 20 left over. 73 goes in 3 times, 3 times 60, with a 13 left over. We bring down our 4. 20 goes to 134 6 times. 6 times 20 is 120. We subtract and get 14. So we had 136, but let's go ahead and figure out what we have left here. So we're going to go ahead and bring down a 0 because we could put a decimal place right there. And 140 divided by 20 is 0.7. So 136.7 was our mean, or our average, and we have thoroughly covered lesson 85, and I hope you enjoyed it and learned a lot. And this is Mrs. A, and may God bless your day.